Hello guys, welcome to the channel. In this particular video, we will be looking at the problem string mirror. So let's see what it says. Here is the problem statement and it says that you are given a string str of length n. You want to choose a non-zero integer k such that you can perform the following operation. Now the operation is take the prefix of the string of length k and append the reverse of it to itself. Your task is to find the lexicographically smallest string that you can get after performing the operation. Now one example is given here. Let me explain. So the string that we have is BAMNO. Now for this string, first of all, let me write all the possible prefixes. The first one is B. The second that we have is BA. After this we have BAM. Then we have BAMN, and at last we have BAMNO. So these are the possible prefixes. And now what I need to do is I have to perform the operation for all these prefixes. So for the first one, when we do so, the operation is append the reverse. So I will have BB, and after this, for this I will have BA, then AB, and for this I will have BAM, then MAB, and for this one I will have BAMN, then NMAB, and for the last one we will have BAMNO, then ONMAB, right? Okay, now out of all these strings, our task is to return the lexicographically smallest string. So you can see that this particular string is the one which is lexicographically smallest string, right? So BAAB is going to be the output. Now I hope you have understood the problem well. So let's talk about the solution. But before this, let's talk about comparing strings first. So how we compare two strings and how we say that a particular string is a lexicographically smaller string. So this is the lexicographical order that we need to follow while comparing the strings. Let's do for this example. We'll start with the first character. These two are equal. What about these two? These two are again equal. And for these two are not equal, right? And we can see that this one is lexicographically smaller character which comes from this order. So this means that this particular string is lexicographically smaller string, right? Now I hope you have understood this concept. So let's talk about the solution. Now I have written the same example, and for the same example, the first approach that will come to your mind is something like this. You can try out all the prefixes and then you can just append the reverse, and then you can check which one is lexicographically smallest, right? So we can do it. What we can do is we can write for k equals to 0, and okay, so even I need to start with 1, right? Equals to 1 and k is smaller than equal to n, and then k plus plus. What I need to do is I need to write the prefix. So I'll write prefix is equal to, how we get the prefix, we use the substring method. So s dot substring, and I'll do 0 to k, right? And after this I need to reverse this prefix. So I'll write reverse of prefix, and once I have got the reverse, then I just need to do append operation. So I'll write this one. Now at this point I will have my like answer, right? And we just need to check, this is actually the result of operation, and we just need to check whether this is a smallest or not. So we will write answer, which is our actual answer, is going to be the minimum of answer and p, right? This is what we need to do. Now again, this minimum operation is basically going to check this particular thing, like which one is lexicographically smaller, right? And we need to initialize the answer with something like maximum value. So how to initialize? We know that this particular character, which is z character, has the maximum lexicographical order, right? So we can start with z, but how many times? In worst case, we can have this particular prefix, and when we append the prefix to itself, then we will get 2x length, right? So we can write a z 2x times. So I'll have 3 4, then I'll write again, it will be 10 times, right? 1 2 3 4 5 6 7 8 9 10. So this is how we can initialize the answer, and we can do this thing, right? Again, this is only the pseudocode. You can't just check using the mean operation. Now I hope you have understood the brute force approach, and the complexity of this approach is going to be let me change the color first. So the complexity will be O of n for the outer loop and O of n for the inner loop. So the total complexity will be O of n square, right? and you can see that for this one again O of n, for this one O of n, and for this one again we have O of n. Why? Because this is string concatenation actually, right? Now I hope you have understood the brute force approach. So let's talk about the optimal approach. In order to explain the optimal approach, I have written one example here, which is BAAZ, right? And for this, the possible prefixes are this one, these one. Now, I'll start with the first one. And for the first one, I'm simply going to initialize my answer prefix by the first character. But what exactly is this answer prefix? You can see that my answer is going to be uh, going to be calculated after performing operation on one of these prefixes. So I just need to find that particular prefix, and once I have that prefix, then I can simply find my answer, right? So I'm initializing my answer prefix with the first character, and then I come to this one. Okay, so I need to check whether I can have this prefix as my answer or not. And how we can calculate this prefix? We can simply calculate any prefix using the previous prefix. Let me explain this. Let's say I need to calculate the prefix till this length, like till this length, and I already know the prefix till this length, so I can simply append this character at last, which means that prefix of I will be prefix of I minus 1 plus current character, right? This is how we can calculate the prefix for any value. So we just need to keep track of prefix of I anytime, and like every time, and we just and after that we can simply calculate the prefix for any particular index. Fine. Now I'm initializing my answer prefix by B, and after that I come here. So I just need to check whether I can append the current character to my answer prefix or not. So how to check this? In order to check this, the first thing that we have is we can simply do it manually. Like for this we can perform operation on this. So when we perform operation on this answer prefix, then we will get B, and after this we will append the same, which is B. Fine. Now for this BA we can append again, do the same operation. We have BA prefix, and then we just need to append the reverse of it, right? So we will do AB. Fine. So these are the two strings that we have. Now out of these two, we need to check whether this one is smaller or not. So if this one is smaller, so I can update my answer prefix. So let's check. You can see that these two are equal, right? And out of these two, this particular character is smaller, right? So we can say that this particular string is lexicographically smaller string than the previous one. Fine. So we can update our answer prefix. Now our answer prefix will be BA, right? Fine. But just have a look at this point. You can see that which character we are actually comparing. This is the current character, because we are currently at this point, right? This is the current character, and this character comes from the previous character. You can see that we are appending the reverse of the same prefix. So when we append the reverse of same prefix, then the last character gets repeated here, right? So we are actually comparing the last character with the current character, which means that I'm comparing these two B, right? So we can uh, instead of doing this, we can simply write if my current character means s of I is smaller than s of I minus 1. Only in that case I can update my answer prefix, right? Now let's come to this point. For this point, again I can do the same operation manually. So I will have, initially my answer is okay. So currently my answer is BA. So when I perform operation on BA, then I get this, and when I perform operation on this one, BAA, then AAB, in that case I'll get, you can see that these two are smaller, right? So whenever we have even you can see that in this case I'm getting this particular string as the smallest string, right? So we can again update the answer. We can again update the answer. So answer prefix will now become BAA. And this means that whenever we have characters smaller or even equal, these two are equal, right? These two previous and current character are equal, so we can see update this thing as this, right? So this is what we have observed till now. Whenever we have the current character as smaller than or equal to the previous character, in that case we can update. What about the greater character? So you can see that here we have the greater character. Let's see what we can do for this. For this, when we try to perform operation manually, then we will have BAA. This is our current prefix, right? So we can perform operation on this. And when we perform operation on this, then we will get BAA Z, then Z A A B. So you can notice that at this point this character is greater, right? So we can't have this in our answer. This means that whenever we have a greater character, then this string automatically becomes greater, right? So we can't add a greater character to the answer. So I can write this observation. We can write this observation simply that if s of I is greater than s of I minus 1. This is an important point. At this point, what to do? At this point, we need to break. Why? Because a prefix is nothing but a continuous string from the start. And whenever we have a particular like character which is not satisfying the condition, so we can't take this character. And when we can't take this character, then we need to stop at this point, right? Because the prefix we need to take from the start. So this means that at this point we need to break. Now we can write this observation. We can write this observation. How we can write this observation? We can simply convert into pseudocode. The pseudocode will be something like for I equals to 1 and I smaller than n and I plus plus. Why I equals to 1? This is a question. I equals to 1 because we are initializing our answer with the first character. You can see at this point, right? So we will initialize our answer with the first character. Answer is going to be s of 0, and when we have the answer is with first character, then we need to start with 1, right? And after this we can simply check if s of I is something which is smaller than equal to s of I minus 1. In that case, we need to add to our answer prefix, right? So this is answer prefix. So answer prefix is basically going to be like this, right? And else we can simply break. Okay, so this is the code that we need to write, right? And we can simply return, at last we can return the answer. But there's a problem with this code. We need to handle one edge case. You can see that we are checking for equal character, but this is not always the case. Let me explain why. I have written this string, and for this string we know one thing, that we have BA, and once we have got one smaller character, so after this whenever we append AAA, so we can have AAA in our answer, right? Why? Because we have already a greater character, and this greater character gets repeated every time, and then we just compare B and A, something like this. Let me explain it. So let's do it for BA and BAA. So for BA we have BAAB, right? And for BAA we have BAA, then AAB. So we know that this B will get repeated somewhere, and before the ending of this string. This is very interesting to note, right? And at this point we can say that the new string is like smaller, right? So that's why we are updating value. But this is not always the case. Let's take a BBA. Now for this string, you can see that these two are equal, but we can't take BB as the answer prefix, because when we take BB as the answer prefix, then we will have BB BB after performing the operation. And and even if we perform operation on the first character, then we will have BB. So which one is smaller? You can see that the first one is smaller, right? So we don't need to update answer in that case. So we need to handle this case. In order to handle this case, we are simply going to check one thing uh, at this point, that if my s of 0 is equal to s of 1, in that case we need to break. Why we need to break? Because in that case the first character is going to be the answer, and first character we have already stored in the answer prefix. And okay, so we can't return the answer here. Instead we need to do one thing, that once we have the answer prefix, then we can simply append the reverse. So we will do answer prefix plus equals to reverse of answer prefix, right? This is what we need to do, and at last we can return the answer. Now I hope you have understood this particular thing. So this is all about this video. Let me show you the code. Here is the code. I have written the code in Java, C++, and Python. So you can see that the Java code is written here, and the code is very similar to the approach that I have explained you. You can see that each time I am just concerned about the answer prefix which I am storing in this variable k. Again, the same thing I have written in C++, and the same thing I have written in Java, like Python, right? Okay, so this is all about this video. I hope you guys like the explanation. If you like the explanation, then you can hit the like button, and if you are new here, then you can subscribe the channel. Thank you.